quadratic. If it is non-squared, that makes it linear. So a non-squared is linear. So in those examples, you're supposed to cross out or circle depending on which example was which. So today's our second day of quadratic transformations. Yesterday we identified key vocabulary and we graphed equations with stretch, compress, and reflect. Today we're going to graph equations that move left, right, or up and down. So we're going to extend our knowledge beyond just y equals ax squared to the two different forms of a quadratic. So vertex form should look very similar to vertex form of an absolute value. Standard form should remind you of standard form of a linear. So go ahead and take a minute and fill in your charts. Again, you can, instead of writing maximum and minimum, you can do max/min. You can just write calculator friendly. Like, you don't have to write everything down. You're just giving yourself a summary of what I've listed. All right. And then we have our key pieces of information that we discussed yesterday. So we're not actually looking at standard form for a while, but it's helpful to have this all in one place. So for some of you that like to have everything nice and neat, you could take a picture of your paper or my board, because this is the key pieces of information we're going to be using for the next 2 weeks in here. Everything off of this summary is pretty much everything you need to know. So like I said, those of you that, like everything in one spot, I would highly suggest sort of getting this all down and having it easy. The vertex is the point with which the graph changes from up to down or down to up. The axis of symmetry is the line that cuts that in half. And then the y-intercept is the line on the y-axis. The min or max occurs at the k value. So the axis of symmetry is the h value of the vertex. The min or max is the k value of the vertex. And vertex form is the form we're focusing on for the rest of this week. Everybody still need this? Okay. Yes. Oh, that's weird. We got moved over there. Okay, are we good now? Alright. So there are a couple translations to parabolas. So like I said yesterday, we did stretch, compress, reflect. Today we're going to do the horizontal, which is movement left or right. Vertical, which is movement up or down. And then sometimes we have a combination of horizontal and vertical, which is movements up and down and left or right. Okay. So let's go through and identify key features of these graphs and make sure we can interpret vertex 4. So our A value is the value in front. So in this case, my A value is 3. My H value is the value that is inside. And if you see that minus, my H value is actually positive. The K value takes the sign with it, so it's negative. So A is 3, H is 4, and K is negative 2. Once I have A, H, and K, all the rest of the information just sort of carries along. Because the vertex is H comma K. So in terms of this problem, my vertex is 4, negative 2. The axis of symmetry is x equals h. The x equals is part of your answer. So in terms of this problem, it's x equals 4. The A value determines if it's a min or a max. So a positive A has a min. A negative A will be a max. So in this case, my A value is positive. So I have a min at my K value, which is negative 2. The domain of all quadratics always is all reals. The domain of all quadratics always is all reals. And the range relates to K again. So that's going to be a negative 2. If it's a min, then my Y values are greater than or equal. If it's a max, my Y values are less than or equal. So since this is a min, my Y values are greater than or equal to my K value, which is negative 2. Okay? So let's look at our next example. I always think it's easiest to identify A, H, and K, and then use that information to plug in. So A is -2. H is the opposite of the inside, so it's -1. And K is 4. So my vertex is H, K. My AOS is always X equals H. Since A is negative, my graph opens down like a frown. If it opens down like a frown, we have a max. And my domain is all reals, always. And my range, since this is open down like a frown and negative, means my y values are less than or equal to my k value of 4. Okay? And then on your graph, we actually have a example of a graph. So let me get my media in check and put up a graph and work through that with you. Okay, so once again, my vertex was -1, 4. So you're going to go over to your graph and plot that point -1, 4. And then what we're going to do is we're going to use a table to help us. So yesterday we kind of talked about our table. Today we're going to elaborate on it further. So the table is going to come from x plus h, ya plus k. So in this case, h is -1. So your table is x -1, y, my a value is -2, and my k value is 4. So yesterday I told you it was kind of like x plus h and then yak, ya plus k. So you're going to fill in your h, a, and k from our problem. Bless you. So x and y never change. It's always 0, 1, and 2. And it is always 0, 1, and 4. And then what we do is apply our changes. So it's 0 minus 1, which is -1, 1 minus 1, which is 0, and 2 minus 1, which is 1. And then it's 0 times -2 plus 4. So anything times 0 is 0, so plus 4. So there's your vertex. And then y times -2 plus 4. So -2 plus 4 is 2. So that means this graph also contains the point 0, 2. And then 4 times -2 plus 4. So that's -8 plus 4, which is -4. So this graph also contains the point y, -4. And then this is why that AOS is so important. So that's my axis of symmetry. So what that means is if you have a point down 2 and over 1, I also have a point down 2 and left 1. I have a point down 8 and over 2. To the right, I have a point down 8 and left 2. So when you graph, you need to always have 5 points, 2 to the left and 2 to the right. So we can see here we have this nice U-shaped curve going through 5 key points. And then the last thing we look at is on being able to write the equation from 2 points given to us. So sometimes you're not going to be given an equation. You're going to be given points on the graph. So we're told we're given the vertex and a point. So remember that the vertex represents H. So we're given H. We're given K. And we're given an X1 and a Y. So we're given an H, a K, an X, and a Y. What key letter am I missing? What letter? What's Ryan? Yeah, I'm missing A. So we're going to have to use our equation to find A. So vertex 4 is Y equals A X minus H squared plus K. So our missing variable is A. So we're going to plug in what we do know, which is H, K, Y, and X. So Y equals A, which we're missing, X minus H squared plus K. So basically we're plugging in what we know, which is Y, X, H, and K. And now we're just going to simplify this algebraically. So order of operations, say parentheses first. So that's 4 equals A. 9 minus 3 becomes 6. Then order of operations, say exponents. And then we're trying to solve for A, so we'll subtract 7. And then to get A by itself, you divide by 36. And negative 3 over 36 reduces to negative 1 over 12. So what that means is A is negative 1 over 12. So the final thing we have to do is plug in A, H, and K to get my equation. So the equation is Y equals negative 112 X minus 3 squared plus K. So your homework is that next page in that handout. So just looking at where we are going and where we have been. So yesterday was Monday. We did day 1. You did the front and the back. Today is Tuesday. We're doing day 2. By tomorrow at 10 a.m., you have to upload day 1 and day 2. And then there's going to be an activity on Delta Math. So tomorrow you need to go to Delta Math to look for your assignment. And then when you come back in on Thursday, we're going to pick up with the next part of that packet. Okay? So again, make sure you upload day 1 and day 2 by 10 a.m. tomorrow. You have the remainder of class time, which is about 15 minutes to work on this.